Hey everyone, my name is Preetham Gupta. I represent Group 4 in the Big Data for Businesses class, and in this video, we're going to go through our Big Data final project. So, the dataset we chose for our analysis is a telecom customer churn dataset. It belongs to a telecom company which is interested in predicting the number of customers who are going to churn. Analyzing the churn data is critical for telecom companies because it gives them insights into the customer behavior and helps them understand why customers are leaving their services. So churning refers to the rate at which customers terminate their services with a company, and analyzing this can help the companies tailor their promotions according to the customer needs. So in our dataset, we have about 7,043 unique values and 21 columns. We're going to use the churn variable as our dependent variable. And since what we're dealing with here is a highly imbalanced data set with more number of customers not churning than the ones who churn, building a model with high predictions is not a good metric to look at. Uh, what we're going with here is sensitivity, which is the measure at which a model determines the number of positive cases. So we're gonna start off by cleaning the dataset in Excel and loading it into the DBFS. Uh, we loaded the data into the DBFS and we created a temporary table to named Telco to look at our attributes. So we also used the describe method to get the non-null count for each column and drop the null values. Uh, Prasanna is going to take over the rest of the code from here. Thank you so much.
Thank you, Pritham, for the information. Now we'll be taking a quick look at feature engineering and the cleaning part of the data. So first of all, here we'll see how we are going to change the columns, like categorical columns. Firstly, the female we are changing it to 0 and male as 1, and then the total charges is changing to double to retain all the decimal values, and then we are changing all the columns where it has yes to 1, and if it's a no, it's a 0. And then we are just looking at the data, like if there are any distinct values for each of the attribute. And then we are calculating some of the statistical variables for attributes like tenure, monthly charges, and total charges. Let's take like the average tenure in this data set is like 32 months, and the average monthly charges are like $64. And then we are just looking at the categorical variable columns. Here we'll be categorizing the values. Like if it's a male, the number of people are like around 3555. Similarly, we'll just take a look at the churn rate in the given data set. It's like 26%. And then we'll just take a quick look at the data, how the churn is affecting all the other things. Let's take senior citizen. Like if it's a senior citizen, there is a churn. It's like 476 almost. And then let's see if there are multiple lines and there is a churn. It's like around 850. And then let's take the streaming the contract, which plays actually an important role. The month to month has a lot of churn comparatively taking a year, 1 year and 2 year. Then the payment method as well, the electronic check has a lot of churn. So we can ask them to change to other payment methods probably. Let's take the churn of the different attributes like tenure, monthly charges. So if the average tenure is like around 17 to 18 months, then there's a lot of churn, which is like month to month probably. We'll take a look at that when we are classifying the models. And also for the monthly charges, when it's going to expensive side, there's a lot of churn. And then we'll be cleaning the data by dropping all the null attributes. Now my friend Gagan will take over. Thank you.
Thank you, Prasanna, for explaining the cleaning part. Let's look at the classification models part. So we have decided to go with these three models, the decision tree, random forest, and the GBT, which is the gradient boost tree classifier. So before we get started, we need to import the necessary libraries as shown here. And we have these three columns as categories in our data. So it's important that we convert them into indexes using the string indexer function. And after we are done with that, we need to convert those indexes into uh, vectors or basically dummy variables in our data. So we need to one hot encode them into these three output columns. So we'll pass these three as the inputs to the assembler. So assembler vector assembler is basically a collection of all the input features, and it contains all the predictors that we have in our model along with the ones that we just one hot encoded. and we get an output column called features, which is basically a vector with collection of all these input columns. So let's start defining our models here. So we have these three models with this definition, and our dependent variable is churn. Then we see the evaluation metrics that we are going to use, and we have three different pipelines for each of the models. So the pipeline takes in the stages, which include the indexers to begin with, followed by the encoder, then the assembler, and the model definition. So then we create a train and test data based on a 70-30 split on the main data frame. And then we start calling the fit function, which is basically where the model actually runs on a distributed fashion in the Spark environment. So we call the pipeline dot fit, and we call the train, or we call it on the train data, and then we do the predictions on the prediction or the test set, which is basically a test data. And dt model, we call the model, it's a transformation function applied on the test data. What this essentially does is it creates a new column called predictions with our predictions for the test data based on this model. So in similar fashion, as you can see, we have created and also we looked at all the metrics like the accuracy, misclassification, recall, and precision. So we similarly we call the RF model and also the GBT model, and we have summarized all the findings in this table. So from this we can pick out our best model. So as you can see, the accuracy is quite similar across all the three models, but the most important metric that we are interested to optimize is the recall. And it comes out that decision tree has the highest recall among all these three models. So we can take our decision tree and start optimizing it further in order to have much better recall. So I have mentioned it here. The metric to optimize is recall, or it is also called sensitivity. And there are various methods addressing this problem. So as Preetham mentioned in the beginning, that we have a class imbalance problem, and we need to deal with how different proportions of classes will affect the prediction. So there are several methods. What we can do is we can either oversample the minority class, or we can undersample the majority class, or we could tell the model that, look, this is a minority class, so you need to consider it by giving it weights. So what we do is we adjust the class weights into the model while we are training the model, and then we can what you call tune the model to have a better recall or sensitivity. So as you can see, we apply the class weight method here. So basically, we have a dictionary that basically defines the weights that we are going to give to the classes. So the majority class has the default weight of 1. So we didn't change that. But the minority class has a default weight of 3. So we increase that. And then we call the our best model, which is the decision tree. We call the classifier on it. And we pass this extra parameter called weight calls, which in general has a default value of 1 1, but here we are explicitly stating the class weights here. And the pipeline is going to be quite similar with all the similar stages, but our model definition has changed this time. And then we call the evaluator, we train it, we do all the similar stuff, and then we look at the metric evaluation. So as you can see, our recall has gone up from 61 to 79, which is what we tried to optimize, and we were successfully able to do that. But the trade-off here is that the accuracy goes down. So one thing we need to keep in mind, that whenever we're trying to either improve the false positive, or that is precision, or false negative, which is recall, and false positive is precision. So when you're trying to improve that or this, the trade-off is that the accuracy will go down. So this is one trade-off that we need to keep in mind. And as you can see, the recall rate or the false negative rate has gone down to 111 from 240 or something. So this model is far better in comparison with the other models that we built, and hence this has been maximized for sensitivity. It is a better choice for predicting the customer churn, and that's it for the project. Thank you.